Welcome to our channel Storm Rider, and the year 2026. The USS Zumwalt DDG 1000 stands as one of the most advanced and unconventional warships ever built for the United States Navy. At first glance, the Zumwalt doesn't look like a traditional destroyer. Its futuristic, stealth-like shape and sharp, angular hull make it appear more like something out of a science fiction movie than a real naval vessel. But beneath that cutting-edge design lies some of the most innovative naval engineering in modern military history. The Zumwalt is not just another ship. It's a statement of what the future of naval warfare might look like. Stretching nearly 610 feet in length and displacing around 15,000 tons, the Zumwalt is considerably larger than the Arleigh Burke-class destroyers that make up most of the U.S. fleet. Despite its size, the ship is designed for stealth. Thanks to its unique tumblehome hull design, radar waves bounce away rather than reflect back to enemy sensors, making it appear no larger than a small fishing boat on radar. This reduced radar cross-section gives the Zumwalt an incredible advantage in modern combat, where detection often determines survival. The ship's sloped sides, enclosed decks, and minimal external fittings contribute to its radar invisibility, while also reducing wind resistance and improving fuel efficiency. Powering this massive vessel is an integrated power system, IPS, a groundbreaking all-electric drive that generates about 78 megawatts of electricity, enough to power a small city. Instead of using separate engines for propulsion and onboard systems, the Zumwalt's gas turbines produce electrical energy that can be distributed anywhere on the ship. This allows flexible power management and sets the stage for future weapon systems like electromagnetic railguns and directed energy lasers, both of which demand immense electrical power. The Zumwalt was one of the first Navy ships to be designed with such futuristic upgrades in mind, ensuring that it can remain relevant as technology continues to evolve. In terms of performance, the Zumwalt is fast, quiet, and agile for its size. It can reach speeds of over 30 knots, or roughly 35 miles per hour, while maintaining excellent stability even in rough seas. The stealthy hull cuts smoothly through the water, significantly reducing acoustic signatures, an essential feature for anti-submarine operations. The reduced noise makes it much harder for enemy submarines to detect the ship using sonar, giving the Zumwalt an edge in undersea warfare. Inside the ship, the level of automation is astonishing. The Zumwalt is operated by a crew of around 140 sailors, less than half the number required to run older destroyers of similar size. This reduced manpower is made possible through advanced automation systems that handle many of the ship's routine functions, from damage control to machinery monitoring. The bridge and command centers are equipped with state-of-the-art touchscreen interfaces and integrated control systems, making operations faster and more intuitive. These modern systems not only improve efficiency, but also reduce fatigue and human error, two factors that are critical in combat situations. The Zumwalt's armament is equally impressive. Its main guns, known as the Advanced Gun Systems, AGS, were originally designed to fire long-range land attack projectiles, LRLAPs, capable of striking targets over 60 miles away with pinpoint accuracy. Although the Navy eventually discontinued the expensive LRLAP program, the Zumwalt still retains its twin 155mm guns, which can be adapted for new types of ammunition in the future. Beyond the main guns, the ship carries an array of missile systems housed in 80 vertical launch system, VLS cells, spread across the hull. These launchers can fire Tomahawk cruise missiles, Evolved Sea Sparrow missiles, ESSM, and standard missiles for air and missile defense. This gives the Zumwalt multi-mission flexibility, allowing it to perform land attacks, anti-air warfare, and anti-submarine operations all from one platform. Another unique feature of the Zumwalt is its advanced sensors and combat systems. The ship uses the dual-band radar, DBR system, combining X-band and S-band radars to track air and surface targets simultaneously. This fusion of radar technologies gives the ship exceptional situational awareness, allowing it to detect incoming threats long before they become dangerous. Paired with the Aegis-like combat management system, The Zumwalt can coordinate with other ships, aircraft, and submarines in a networked battle environment, sharing data in real time. The ship also boasts advanced electronic warfare capabilities designed to jam, deceive, or disable enemy sensors and communications, making it a formidable opponent in both offensive and defensive scenarios. In terms of design philosophy, the Zumwalt-class destroyer represents a shift from brute force to technological superiority. It embodies the idea that information dominance and precision strike capabilities are just as crucial as raw firepower. Its smooth radar-absorbent surfaces, integrated exhaust systems, and enclosed deck equipment not only enhance stealth, but also reduce maintenance demands. Even the ship's deckhouse is made of composite materials rather than steel, lowering its radar profile and improving overall balance. These innovations didn't come cheap. The total cost of developing and building the three Zumwalt-class ships exceeded $22 billion, but they paved the way for future generations of surface combatants. Beyond combat, the Zumwalt's versatility allows it to perform humanitarian and special operations missions. Its large deck space can accommodate helicopters, drones, or even future unmanned surface vehicles. The spacious interior can be reconfigured to carry troops, medical teams, or relief supplies. This adaptability makes it a valuable asset not only in warfare, but also in peacetime operations, disaster relief, and intelligence missions. As of 2026, the USS Zumwalt continues to serve as a testbed for next-generation naval technologies. The Navy has begun integrating hypersonic missile systems aboard the ship, a move that could redefine its strike capabilities. Hypersonic weapons travel at speeds greater than Mach 5, making them nearly impossible to intercept. If successfully deployed, they would transform the Zumwalt into one of the most lethal surface vessels in existence, capable of striking high-value targets thousands of miles away within minutes. Despite its groundbreaking design, the Zumwalt program has faced its share of criticism. High costs, technical challenges, and changes in naval priorities led to the cancellation of further production beyond the initial 3 ships. Critics argue that the program's expense outweighed its immediate benefits, while supporters believe the technological advancements introduced by the Zumwalt were essential for the Navy's evolution. Regardless of the debate, there's no denying that the Zumwalt has influenced naval architecture and warfare strategy worldwide. Many of its design elements, from stealth shaping to integrated power systems, are now being considered for future classes of ships. The USS Zumwalt DDG 1000 is more than just a destroyer. It's a symbol of innovation and ambition. It demonstrates what's possible when technology, engineering, and strategic foresight converge. For the casual observer, it's an impressive futuristic ship slicing silently through the ocean. For military analysts, it's a platform packed with potential and lessons learned. In 2026, as the world's navies adapt to new challenges in cyber warfare, drone integration, and long-range precision strikes, the Zumwalt remains a floating laboratory for the future. Its sleek lines, electric heart, and digital soul capture the essence of 21st-century naval power, a blend of stealth, speed, intelligence, and adaptability that ensures it will remain one of the most fascinating warships ever built.